Before we deep dive into the exam blueprint, or for that matter, before we learn any new topic or technology, I think it is important for us to understand the why and the what behind it. And that is exactly what we are going to do in this video. We'll start off by discussing why it is important for us to learn how to design a good wireless network. I mean, why can't we simply deploy the latest and the greatest of the wireless solution out there and be done with it? Why do we need to invest our time, our energy, and our money in planning and designing a good wireless network? And once we have understood the need to design a good wireless network, we will discuss what are the design methodologies and the strategy defined by Cisco that helps us in designing such wireless networks. Let's begin by understanding how the wireless landscape has changed over the last 20 or 25 years or so since wireless networking standards were first released for commercial use. And if you're as old as me, you may remember that back in the day, our computers did not used to provide native wireless connectivity. In fact, if you needed the connectivity option, you will have to go out and purchase a separate PCI card with wireless network interface inbuilt on that card, which looked something like this. And if you're as old as me, you may remember that back in the day, our computers did not used to provide any native wireless connectivity option. In fact, if you needed some sort of wireless connection or wireless connectivity option, you will have to go out and purchase a separate PCI card with wireless network interface card built on top of the PCI card. Trying one more time. If you are as old, no. And if you are as old as me, you may remember that back in the day, our computers did not used to provide the native wireless connectivity option. In fact, if you needed wireless connectivity, you'll have to go out and purchase a separate PCI card with a wireless network interface card built onto that PCI card, which looked something like this. And if you are as old as me, you may remember that back in the day, our computers did not used to come with an inbuilt wireless connectivity option. And in fact, if you needed the wireless connectivity, you will probably have to go out and purchase a separate PCI card with a wireless NIC built into that PCI card, which looked something like this. For those of you who may have not seen this, this is a zoomed in picture on the left hand side of a PC's motherboard, which has some PCI and PCI expansion slots. And hopefully you are able to see in this video that some of these expansion slots are marked as PCI and PCIe. Uh, in more simple terms, these were the slots which allowed us to expand the capabilities of our PCs in case if those capabilities were not there at the time of the manufacturing. Case in point, the wireless connectivity option. So in case if the PC did not had the inbuilt wireless NIC at the time of manufacturing, you could go out and purchase a separate external wireless NIC, which looked something like this, and it may or may not have these external antennas, right? So sometimes these cards can have an internal antenna which is built right here on this chip. So depending upon what model of wireless NIC you would probably purchase, it may or may not come with these external antennas. But anyways, coming back to the point, so you would have to purchase these external wireless NIC and then plug these wireless NICs into these PCI slots to make your PCs wireless compatible or allow those PC to access the wireless medium. Now, for some of you, this may look and sound very alien, but trust me, this is how some of us used to get the wireless connectivity back in the day. This was mainly because the wireless technology, when it was first integrated in the enterprise networks, it was simply just a fun way to have a pretty basic network connectivity. I mean, except maybe transferring some pretty small files and sending some emails, you would not rely on the wireless networks to perform any important tasks. Now, fast forward that to today, where now we use the wireless medium extensively and exclusively, even for maybe mission critical applications like monitoring patient vital signs in healthcare industries, remotely controlling manufacturing robotic machines, or our wireless IoT sensors for home and industrial monitoring purposes. it is interesting to note that we have come a full circle of sorts, where now almost all of our computing devices are either Wi-Fi first or Wi-Fi only. And now today, if you need a wired connectivity on your laptops, guess what? You will have to buy an external accessory which now looks something like this. Right? So hopefully this is something that is very, very familiar to you. These are your typical USB-C to RJ45 connectors that you would now have to purchase in case if you need the Ethernet connectivity or a wired connectivity on your laptops. The evolution of wireless as a networking technology has helped us in using wireless as a primary medium of connectivity. Now, if I scroll down and if we take a look at this chart, it shows how wireless has evolved from the initial phases where wireless was mostly perceived as something of a being nice to have a technology to a now technology that can support even mission critical applications. Right? So in this chart, we can see that how wireless speeds have continued to increase from the initial or the original Wi-Fi standards back in late 90s or early 2000s, right? So going from starting from 11 Mbps to going up to 5 gigs of speed as of now. And this is continuously evolving as we speak. Although today's speeds are incredible as compared to the original IEEE 802.11 standard, and the original standard is also sometimes referred to as 802.11 prime. But we will get into all these wireless networking standards in one of the subsequent videos. But for now, we must understand that getting the fastest and the greatest speed is not our goal. I mean, it's not our only goal. There's so much more that goes into designing a good wireless network apart from providing the fastest speed to the end users. We will quickly discuss some of the factors that supports this statement. Now, along with our computing devices, we have also evolved the way that we work. Now, earlier, in fact, this may be true just the pre-COVID era as well, that uh, before COVID, we were most likely fixed to one particular desktop stations where we used to go to the office or place of work, and we used to have our assigned workstations and our specific desks and used to log in and complete our day-to-day activities there. But if you take a moment and realize how do we work today is completely different, right? So we are no longer tied to a specific workstation or in fact a location. We generally work out of anywhere, and even in our office environments, we have moved over from our traditional workspaces where we used to have a specific desks assigned to us to a more modern and open office spaces allowing us to collaborate more. And due to these requirements, the RF propagation requirements have also changed within the confines of our workspaces. Similarly, the applications that we use today, they have also evolved drastically. Now, most modern applications that you will see around you and even in the businesses are real time in nature. And due to this requirement, they can be either bandwidth hungry or they can be very sensitive to the latency in the network, or they could require a combination of both. As wireless network designers and architects, we should keep these app behaviors in mind when we are designing and architecting the wireless network. And not only that, we have also grown from using one device per user to now using and owning multiple devices per user. So we have grown from using just a single laptop per user to maybe three or sometimes even four devices per users. Right? So maybe this guy is carrying a laptop, maybe this is his smartphone, this is the tablet that he is using. This guy may also be wearing some sort of smartwatch for some reasons. And this is really very important for us as network designers and network architects to understand that this has increased the device density. And in the special purpose areas like auditoriums, the stadiums, airports, even theaters, the user and the device density is even higher. So, as a network designer, we should also understand these requirements as we design a wireless network around it. that serves not only the users in terms of the coverage requirements, the speed requirements, the user density requirements, but most importantly, we are now converging our networks to provide a seamless user experience to our users. Hopefully, we now understand the need for us to know and understand how to design a good wireless network, keeping all these complexities in mind so that it meet our requirements and our goals. And in order to come up with a design, we need to start somewhere. We could either just make it up as we go, or we could follow a more structured methodology, which, in my opinion, is a better approach. Now that we know the why of it, let's discuss the what. Now that we understand the why, let's shift our focus to the what. The benefit of using a structured methodology is that other people have already done most of the hard work for us. They have put together a structured set of rules so that we can follow them. And it is important to note that there are many structured methodologies out there, but our focus in this course will be the one which is defined by Cisco, which is known as PPDIOO methodology. Now, what in word is that? Don't worry, we are going to discuss it. Since you are taking this course, I assume that you have some experience with managing or deploying networks in some capacity. And if you have done that, we know that it's almost never the case where you deploy the network once and you are done with it and you never go back and touch this network. So, this is never the case. In fact, as we work on a network and we manage a network, we look for ways to continually optimizing and improving this network. So it's not a linear phase. In fact, it is a cycle. And that is what PPDIOO defines for us. So let's take a quick look of how does this work. Right? So let me quickly draw out this little cycle out for you. And then we are going to discuss what is PPDIOO. So as we discussed that this methodology has been defined by Cisco. So it stands for prepare, plan, design, implement, operate, and optimize. So we go from one stage to another and we'll take a look at each of these stage in a moment. Now let's discuss the first phase, which is the prepare phase. Now, in this phase, essentially what we are trying to do is trying to capture the customer requirements on a very high level or the customer goals for the network. So, for example, they may have a goal or a requirement to implement Wi-Fi 6E. Once we have discussed the requirements and the goals on a very high level with the customer, it is also important to discuss what is the budget allocated for this project because we don't want to exceed this budget. And based on this budget and the requirement, we will come up with the product or the wireless solution, in this case, the solution which supports Wi Fi 6E, which also meets the budget and the end result or the end goals for this project. And once we are done with the prepare phase, we'll move on to the plan phase. In this phase, we will try and assess the underlying network and see if it is capable of supporting the new goal, which in this case is supporting the Wi-Fi 6E solution. So for example, you may have some older switches which are not capable of powering up the new access points because of the power requirements or the PoE requirements for the new access points. And if that's the case, then probably we'll have to go back to the prepare phase and discuss the budget with the customer because they'll have to upgrade some portion of the underlying network as well. Now, once we have assessed and ensured that the underlying network is in fact capable of supporting the new solution and we have enough budget, the next step will be to create something called as a BOM or bill of materials. BOM is essentially the list of equipment that the customer needs to order to deploy this new solution. But it is important to note that this does not only contain the hardware list of equipments. Of course, it does contain the hardware. So, for example, what are the model of the Cisco access point that customer have to purchase for the solution, and what are the different wireless controller, for example. But this is not just the hardware list. It also includes the software, what are the different licenses that they may have to purchase, what are the different, let's say, SFP modules that they have to purchase, which are compatible with the new solution. And it may also include what are the different power adapters that they may have to order along with these list of equipments. So it is a very extensive list. So it does contain what are the quantities for each equipment, quantities for each licenses, and maybe I can show you an example of a sample BOM. So this is an example of a very simple BOM or bill of materials. So here you can see what is the WLC model, the Cisco WLC model that has been selected for the solution. What are the different licenses that may be required to serve the purpose? What are the compatible rack mount for the wireless controller? What is the power supply for the wireless controller? So on and so forth. And then you can also have a column that defines what are the different quantities of each of these line items. And remember that this form or bill of materials can be as extensive as you want, so that you capture everything, all the minute products and the solution which serve your purpose or which serves the project should be listed here within this BOM. And of course, this BOM or this bill of materials should be within the constraints of the budget of the entire project. So once we have completed this exercise, the next phase that we move on to will be the design phase. And as the name suggests, in this phase, we will come up with a wireless network design which includes all the solution components which have been selected in the plan phase. This phase may also include the modeling and testing in the form of wireless site surveys. And once we are done with the design phase, we now move on to the next phase, which is the implement phase. In this phase, as the name suggests, we will go ahead and actually implement the wireless solution, which we have designed in the previous phase. Now, this may include the racking and stacking of the equipment, the powering up of the equipment, and also doing the configuration of the equipments. And that will include the configuring the WLC, configuring the access points, and so on and so forth, or whatever equipments are part of this wireless solution. Now, once we are done with the configuration, another important aspect of the implementation phase, at least from the point of view of this specific project, is also doing some sort of validation testing. Now, this testing is important because it allows us to validate and confirm that the system is performing as per the expectation. Once we have completed the implementation phase, now we move over to the next phase, which is the operate phase. In this phase, we start managing the network so that it is now serving the end users. So now this network has been put into the production. We will now go ahead and perform the day-to-day tasks, the day-to-day activities of managing the network, monitoring the network, and in fact, even repairing the network if required. All right, so this brings us to the next phase, which is the optimize phase. In this phase, we will continually try to reevaluate our business requirements or business needs and see if they have changed over the period of time. If there are changing business needs, architectural needs, or performance requirements, then we will have to ensure that the solution that has been implemented remains the best possible solution. And as you can imagine, all the different phases that we have been discussing so far, the prepare, plan, design, implement, operate, and optimize, they are not linear in fashion, right? So this is a life cycle of a network that has been defined by Cisco. So sometimes you will probably have to jump back and forth between these phases. So for example, if you are into a prepare phase and you move over to the planning phase, and then you found out some discrepancy, then you may again have to go back to the prepare phase. Similarly, the designing and the implementation phase, we can sometimes go back and forth. So you see that this is a continuous cycle of sorts, hence the name PPDIOO life cycle. And I know sometimes it gets a little difficult to remember all the different phases and stages of PPDIOO, but Cisco has done us some favor in simplifying this methodology and simply coming up with a PBM methodology, which is which stands for plan, build, and manage. So essentially, in this methodology, your plan phase covers the prepare, the planning, and the designing phase, as described in PPDIOO methodology. In the build phase, it directly maps to the implementation phase. Similarly, the manage phase, it maps to the operate and optimization phase. So we do have a direct correlation or a direct mapping between the PBM methodology and PPDIOO methodology. All right. So our key takeaway from this entire video is that the Cisco methodology of PPDIOO is a life cycle of network projects because, well, it really goes around in circles from one phase to another as and when needed. And PBM is in fact a simplified version of PPDIOO, and we should know which PPDIOO phase maps to which PBM phase. With that, I'll see you in the next video. I hope this was worth your time. Thank you.